At the eastern end of Long Island Sound, an area between the tip of Fisher's Island and the North Fork of Long Island, called the Race, is known for its strong tidal currents. This is where the Atlantic Ocean meets the estuarine waters of the Sound. Twice daily, tidal waters move in and out of this narrow channel with a force ranging from about 4 to nearly 7 miles per hour. Could the mechanical energy of the tides in the Race one day be harnessed to light our homes and power our computers? Roger Basin, president of Natural Currents Energy, hopes so. Across the country and the world, the possibilities of tidal power, a promising form of renewable energy still in its infancy, is being explored. Basin has set his sights on the Race as a possible location for an array of tidal turbines. In December 2012, he obtained a preliminary permit from the Federal Energy Regulatory Commission to conduct testing and study environmental impacts of developing this area for tidal power. The Race, said Basin, is one of his company's priority sites. In a 2011 report by Georgia Tech Research Corp., commissioned by the U.S. Department of Energy, the Race was identified as one of about 35 coastal areas nationwide with the theoretical potential to produce more than 100 megawatts of power from tidal turbine arrays. The central portion of the Race could produce 186 megawatts, while the north and south ends could generate 21 and 28 megawatts, respectively, the report said. Initially, Basin is looking to generate only 5 megawatts of power, enough to power about 4,000 homes. He sees this as a demonstration project designed to establish the feasibility of the technology and win public acceptance to pave the way for future larger projects. Some 130 miles away in New York City, Ron Smith and his partner Trey Taylor are demonstrating that tidal power can become a reality. Their company, Verdant Power, generated power from turbines in the East River off Roosevelt Island last year as part of a pilot project. The power produced traveled through this connection to supply electricity for a convenience store that serves the island, accessible by subway from Manhattan. Later this year, Verdant plans to launch the next phase of its project when it installs 30 turbines in the water. Here is Smith talking about the project.
For a license from FERC to deploy 30 turbines along this space, and that's the license we got last January. So ultimately the turbines will run from here up to about half a mile up the river there on this side.
Verdant Power's turbines look a lot like wind turbines, only shorter. In the Irish Sea and in the Netherlands, tidal turbine projects use similar designs, but there is a wide variety in this still developing technology, and it's unclear which design will ultimately dominate. Between Lubeck and Eastport, Maine, Ocean Renewable Power Company is using a device that looks something like an old-fashioned push lawnmower to generate power from the tides in Cobscook Bay. In the Race, Basin is planning to use his own Sea Dragon turbine design, which looks something like a thresher used on farm fields to separate grain from straw. Here is a brief demonstration of how a tidal turbine works to generate electricity. This is a model of a tidal turbine adapted from plans available on the Department of Energy's website for a model wind turbine. The design was modified to look like a kind of tidal turbine that now operates in the Irish Sea. The blades turn and generate electricity both with the incoming and the outgoing tides. Here, the tides are represented by this board with plastic strips that would turn the blades as the tides flow in and out. The blades are attached to these hubs, which fit into small generators. The generators, which are adapted from readily available low voltage motors, turns the mechanical energy of the blades into electricity. The electricity is then sent through a wire that's connected from the back of the generator and goes through these pipes and out through this opening. If we hook the wires to this multimeter, and then manually turn the blades. We get a reading on them on our multimeter of about 0.3, 0.4 amps. If we reverse the power and hook these wires up to this AAA battery, we'll get a better idea of how the blades would turn if it were spinning with the full force of the tides. Now, if we get a reading on our multimeter, let's see. We get a reading of about 20, 22 amps.
Okay.
Under Beson's plan, the power generated by the turbines would be sent to an existing 1.2-mile underwater cable that now supplies power to Fisher's Island. The cable delivers power from Groton Utilities' generating plant. Any excess power generated by the turbines not used by Fisher's Island could be sent to Connecticut via the cable. With all of these projects, the regulatory, environmental, and financial hurdles are significant. It takes a long commitment on the part of developers to get a project from concept to reality. But compared to other forms of renewable energy, tidal power has some key advantages. Tides are predictable and continuous, which are very attractive qualities for practical energy generation. The significant promise of this technology, together with the need to find new ways to generate energy that don't produce greenhouse gas emissions, have sparked a lot of interest. In the past few years, FERC has issued 100 preliminary permits to tidal energy developers, and in March it announced an agreement with the Coast Guard to cooperate on navigation and other issues arising from tidal energy projects.